Ya, Assalamualaikum warahmatullahi wabarakatuh. So today I will explaining a code here about code and implementation about maze solving and life follower, or maybe life follower. And in here we use a tiny bit one, tiny bit this thing is tiny bit and also microbit. Here microbit, yes, and yeah, microbit it says. So I will explain the code from the start. So here it will first show an icon which is which is a house here or home. There's so many. I just give it here for testing because sometimes it's corrupt because yeah, you know, as you can see I use Linux and it cannot like sending something like that. I never try anything with Linux, but just trying now. Then we set a set calibration here to 500. We will talk later about calibration here. Then the turn speed, so we can change the turn speed of this turn speed, but I think it's people very lazy to change it, so better use Arduino. Then there's a 3 or 2 function here. The first one is a plan A. Plan A is here for the turning thing, and here the plan A. So basically it describes where can you turn, and if it's not time, so it will move forward. And here call maju or forward. Here yeah, forward. In here, as you can see, there's like extra comment here code, and usually line follower is this thing, except if they use something more complex, more faster, which is like PID, which they doesn't do this. Since tiny bit use 2 sensors, so it's really weak for this. It's not supported, not good. Bad choice, yes. And then there's also a function for time. Is it the time to turn or not? So it will input the time where you want to move, when you want to move, and it out the calibration, so the function called multiple times. Time it cannot just move with just a single function called, so calibration, the function of calibration is that, so it will call multiple times. So there's like, for example, from the code before it used 500, right? So it will, the function will call in the middle of time, minus calibration and post calibration, so that means the calibration is 2 times, and it called like 1000 milliseconds. And if it's the time to move, it will return 1, and if it doesn't, yeah, return 0. And then here is the main A. Actually there are so many turn, but since it's not accurate, the sensors little, and I really not really like it, so we use a couple turn here, and this one, yeah, for total. This is for all forward. Here the time here is not you know, it's different for every track. So we tried like so many times, multiple times, to get the perfect time here, and then the output may not accurate because there are so many factors here to make it not perfect, such as the battery, the motor, the weight, others. Yeah, so many factors to make it broken, really hard. But yeah, it's okay. So in here, this is the first turn. You can adjust. It's not always like in a good pattern or in good position. Like the first one is correct. No, you don't need to do that. But you know, it's more better to make it adjust the good position. Yeah. And here, first turn, second turn, third turn, fourth turn here, and the calibration here is affect all of this function. So you may need to change the calibration also, not just the time. But there in my track, where we move the car into the right one in the first turn, and then the right one again at the second turn, the left one and the third one, and the left one to the fourth one. And here, since it's the plan called first only single time, so we need to slope here, and the condition is that if the time is less than 10,000 or 10 seconds, it will run the code, and it doesn't, it goes to the next pointer here, which is it tell to stop. Really cool. And the tiny bit I said before is not accurate, so when we demonstrate or implement it, it's not really that accurate, but we tried our best, and maybe that's what, maybe I don't know what we've done. What about you guys?
Aku ada